So in our previous class we were discussing about finding the pedal equation for the polar curves. We are using the equation P is equal to r sin pi, where pi denotes the angle between the tangent vector and the radius vector, this one. Now we shall obtain another different form of the equation from the same equation, that is P is equal to r sin pi. P is equal to r sin pi ಇದನ್ನು ಯೂಸ್ ಮಾಡಿ ಇನ್ನೊಂದು ರೀತಿಯಾದ ಪೆಡಲ್ ಫಾರ್ಮ್ equations ನಾವು ಕಂಡುಹಿಡಿಯೋಣ. So we are already having tan pi is equal to r divided by dr by d theta. So I can write it as sin pi divided by cos pi is equal to r divided by dr by d theta. Or in other words, sin square pi divided by cos square pi is equal to r square divided by dr by d theta whole square. And simplifying that expression, we may obtain sin pi is equal to r divided by square root of r square plus dr by d theta whole square. So substituting this relation in the equation 1, p is equal to r sin pi, we have p is equal to r into sin pi, that is p is equal to r square divided by square root of r square plus dr by d theta whole square. And inverting this relation, that is, we can write 1 by p square is equal to what you can say, r square plus dr by d theta whole square. That is, here we can note that the square of the denominator, that is this one, and in the denominator we have square of the r square, r to the power 4. So simplify this expression, we write it as 1 by p square is equal to 1 by r square plus 1 divided by r to the power 4 into dr by d theta square. Of course, here also we can take 1 by r square common, and we can write 1 by p square is equal to 1 by r square into bracket 1 plus dr by d theta divided by r its square. Anyhow, we shall remember only this form of equation. This form of equation, that is 1 by p square is equal to 1 by r square plus 1 by r to the power 4 into dr by d theta whole square. So here I have written the pedal equation. To obtain the pedal equation of a curve with polar form r is equal to f of theta, we eliminate theta between this term. 1 by p square is equal to 1 by r square plus 1 by r to the power 4 into dr by d theta whole square, and r is equal to f of theta. The pedal equation is obtained. In the previous section, we have also noted that the pedal equation is also obtained by eliminating theta and pi between p is equal to r sin pi and tan pi is equal to r divided by dr by d theta. The most common method is this one, that is, we eliminate theta and pi between p is equal to r sin pi and tan pi is equal to r divided by dr by d theta. And very rarely we use this form, that is 1 by p square is equal to 1 by r square plus 1 by r to the power 4 into dr by d theta whole square. So let us take one example. Example 1, show that the pedal equation of the spiral r is equal to a times sec hyperbolic m theta is of the form 1 by p square is equal to a divided by r square plus b, that is p to the power minus 2 is equal to a into r to the power minus 2 plus b. So solution 1. Given curve is r is equal to sec hyperbolic m theta. So differentiating with respect to theta, we have r dash is equal to tan hyperbolic m theta into sec hyperbolic m theta into m. Hence we have tan pi is equal to r divided by dr by d theta, r which is equals to 1 divided by m into tan hyperbolic m theta. So using another form, we have 1 by p square is equal to 1 by r square and so on. Of course, simplifying all these expressions, we have this term 1 by p square is equal to 1 by r square plus 1 by r square into bracket m square. In place of tan hyperbolic square m theta, we have written as 1 minus sec hyperbolic square m theta. 1 minus sec hyperbolic m square. Of course, you can confirm it by using another form. So sec hyperbolic m theta is the given equation of the curve. R is equal to sec hyperbolic m theta is the given equation of the curve. So I can replace sec hyperbolic m theta in this equation by r. So I can write 1 by p square is equal to 1 by r square plus 1 by r square into bracket m square into 1 minus r square. And here again we can take 1 by r square common. So we can write 1 by p square is equal to 1 by r square into m square into 1 minus r square. Or in other words, we have 1 by p square is equal to m square by r square. M square by r square plus or minus m square. Instead of, we can write. So 1 by p square is equal to m square into r to the power minus 2. That is m square by r square. I written as m square into r to the power minus 2. Of course, it is minus m square, but can be replaced by a constant. So what we can say, this is of the form we have. This is of the form big A divided by r square. That is what we have. Big A divided by r square. Big A divided by r square plus b of this form. Plus b form. So it is in the given form, and hence we can solve the example. So let us take another one example. Find the pedal equation of the curve r to the power m is equal to a power m cos m theta. This is I already solved in my previous notes, but still let us take here we cannot use the same form. 1 by p square is equal to 1 by r square into bracket 1 plus r dash divided by r whole square. So here we will be using the earlier method and we can find out. So find the pedal equation of the curve r to the power m is equal to a power m cos m theta. So here we have taken the given equation of the curve r to the power m is equal to a power m cos m theta. Differentiate with respect to theta. So we have in the RLHS side m into r to the power m minus 1 into dr by d theta, which can be replaced by r dash. Dr by d theta is equal to minus m into a power m sin m theta, and hence we have dr by d theta divided by r is equal to minus tan m theta. Of course, you can divide this equation r to the power m is equal to a power m cos m theta divided by the second equation m into r to the power m minus 1 dr by d theta is equal to minus m into a power m sin m theta. You may note that dr by d theta divided by r is equal to minus tan m theta, or I can write 1 by r into dr by d theta is equal to minus tan m theta. Of course, what is required here, tan pi is equal to r divided by dr by d theta. That is the reverse of this term, inverse of this term we can say. So r divided by dr by d theta is nothing but 1 divided by minus tan m theta. 1 divided by minus tan m theta, or I can write it as tan pi is equal to minus cot m theta. Minus cot m theta. So I can write minus cot m theta as tan of pi by 2 plus m theta. Tan of pi by 2 plus m theta, which is nothing but minus cot m theta. So tan pi is equal to tan of pi by 2 plus m theta, and hence what we can say, pi is equal to pi by 2 plus m theta. And when we obtain the expression for pi, we replace pi in this expression, p is equal to r sin pi, by this pi is equal to pi by 2 plus m theta. So we have p is equal to r into sin pi by 2 plus m theta, and we know that sin pi by 2 plus m theta is cos m theta, so we have r into cos m theta. And again from the given equation r to the power m is equal to a power m cos m theta, we can write cos m theta as r to the power m divided by a to the power m. So we have p is equal to r into r to the power m divided by a power m, or p is equal to r to the power m plus 1 divided by a power m. So this is the required equation of the pedal form. Of course, you try to find out the pedal equation of this curve, we shall discuss, and also we shall discuss